So I'm very happy to introduce our speakers today. We're going to begin with Vandana Rao, who's the Director of Water Policy at the Massachusetts Executive Office of Energy and Environmental Affairs. Vandana is responsible for developing policy and providing input to the Secretary of EEA on water resource issues across the state. These include issues such as water quality and quantity, drought, water conservation, wastewater, habitat, watershed management, climate change impacts, and stormwater. She manages the state's drought assessment and response, leads the development and update of the Massachusetts Water Conservation Standards and the Interbasin Transfer Act regulations. Vandana is also very involved in climate change issues as they relate to water and is leading the state's effort to update their climate predictions to a more downscaled level, which I'll be interested to hear what that means. She was the editor of the Massachusetts Climate Change Adaptation Report in 2011. Tara O'Hare is joining us from US EPA. She currently serves as the implementation and commercial outreach lead for EPA's WaterSense program in Washington, DC. Ms. O'Hare is responsible for program operations, partner support, and outreach to commercial and institutional facilities. Tara led the development of WaterSense at Work, best management practices for commercial and institutional facilities, and has delivered trainings and webinars to a wide variety of stakeholders from all parts of the commercial building sector. And then finally, Jim Kane will be speaking with us. Jim is, as you all know, a senior engineer at the Massachusetts Office of Technical Assistance and Technology. Jim provides pollution prevention and compliance assistance to manufacturers of metal products, electrical products, and chemicals. He also has organized OTA's Industrial Water Management Workshop Series and worked on water conservation projects. More recently, Mr. Kane has been providing assistance and training for energy efficiency project planning. So I'm really happy to welcome all three of you to our discussion today. And I'm going to go ahead and stop sharing and invite Vandana to share her screen and kick off this conversation. Thank you so much. And you are on mute, just a reminder.
Good afternoon, everybody, and thank you so much, Pam, for that introduction and for pulling this session together on water conservation. Let me share my screen through. Are you able to see my presentation?
Yep, thanks. You can put it in, there you go. Yes. Thank you.
Do you see it in presentation mode? Sorry,
no,
I have to.
No, we're just, we don't, there you
okay.
go. Now we got it. Thank you.
So today I'll just give you some background on what it is that we are currently experiencing here in Massachusetts and why our concern for water use is perhaps a little bit more elevated in light of climate change, and not only what we're experiencing, but certainly what we are expected to experience in the next several decades. Towards the end of the presentation, I'll bring it back to all of you, what it is that we as a collective can do to help prepare ourselves and make our systems more resilient, but really to make sure that in light of these extremes that we are experiencing, how can we manage our buildings and our systems in a better way. So granted that we do not necessarily see things like this. These are photographs from my home city where I grew up. And this was a way of life each year, and still is a way of life each year during the monsoons. This particular event, I believe it was in 2015 or 2014, was a particularly bad one where the city of Bombay or Mumbai received over 30 inches of rain within an 18-hour period. And to put that in perspective, here in Massachusetts, we do receive quite a bit of rain. Our average rainfall on an annual basis is about 46 to 48 inches of rain throughout the year. So you can imagine how much of a pressure getting 30, 35 inches of rain within an 18-hour period can put on all kinds of infrastructure within a city. So, yep, we don't have this, but then again, maybe we do. And some of these events that we've experienced in over the past decade are really showing us that we too are quite vulnerable, even though we don't get monsoons like a lot of Asia does. We get our own types of storms, and both winter and other storms that put a lot of pressure on our human way of life and our human infrastructure. As you can see right here, this is from a little over a decade ago, but we got 4 inches in 1 hour, which is a lot compared to what we typically get. And you can see that that has flooded this downtown area. In the left one is from the city of Cambridge. I believe we had somebody from the city of Cambridge take that photograph, but the right photograph is from Rhode Island. In addition, we're also seeing a lot more of this. As you can see, basements are being flooded, first floor level is flooded, but really our infrastructure is being particularly impacted. Our roads, our bridges, and our waterways are really not able to handle this high influx of water over a very short period. We call this as sort of high burst, high intensity events that we are seeing that completely crumble the infrastructure, as you can see right here in this photograph. This is just one example, and this has happened extensively across the Northeast in several of our neighboring states, as well as in Massachusetts, where roads have completely succumbed to the high velocity of water that gushes from underneath and takes it out. And this particular slide, the reason why I put this in is because the city of Worcester, and this has happened even last year since these photographs were taken, the city of Worcester, as well as several other cities in Massachusetts, are really vulnerable because of the high amount of impervious cover that they have. And also just the way some of the weather patterns have been impacting them. But this flooding event happened over a weekend in October of 2016. And this event is particularly sort of concerning for us is because this happened right in the middle of when we were in one of our worst droughts. Who would think that while this particular region of the state was in a level 4 drought, 4 being the worst, not really the worst, but the emergency or level 5 is the worst. So level 4 is right up there. And the city of Worcester, if you remember several years ago, had bans on for selling water, tapped water in their restaurants around town. And they had many other water conservation measures in 2016 to be able to ensure that their water supplies are really available through the winter. And right in the middle of that was this big high burst rain event that caused all this flooding. So it's this juxtaposition of these two extremes that we are seeing more and more of right here in New England. And Hurricane Sandy, which happened in 2012, was really a whole other story. That brought in so much water that this wastewater treatment facility was completely inundated. So it's trying to have impacts not only with road flooding, but on some of the very basic infrastructure systems that we take for granted: water supply, wastewater, being able to flush our toilets on a daily basis. If your wastewater treatment plant is flooded, it's not going to take water in. There are going to be backups in people's homes. So it does affect you and I on an everyday basis. And those of us that have not been affected so far are really lucky to have been in those areas where some of this inundation didn't happen, or these high burst events sort of missed us. So we as sort of planners and those of us who work in the state that think about the impacts of this, one of the things that we are trying to see is, is this just a random event that happens once in a while and we just have to deal with it? Or is it something that's a little bit more telling of a changing climate? And is it something that we're going to be seeing more of? And we're here in Massachusetts are blessed with a really long history of of data. And in fact, our precipitation data goes back over 100 years. So I just took this little sliver, not little, but the sliver of about an 80, 90-year period. And you can see a bunch of these extremes, which I've highlighted here in red. So several of these higher extremes that you see up there, but you also see these dips at the bottom that are showing some of these time periods where there have been droughts. In addition, temperature has also been increasing. In fact, this summer we had one of the hottest summers in Boston, going back to records that started in the 1870s or 1880s. If we look at this from last year, it also shows that last year was a record warmest within the 126th year of record keeping. So each year seems to be getting worse, and temperatures certainly are rising. And we're seeing a lot more of these higher than normal temperature days. So by that, I would say anything above 90 degrees. So the above 90-degree days, I think a decade ago was almost unheard of around here. And this year, we already, I think, had 4 or 5 or 6 of those. So every year we seem to be increasing, not just in how high the temperature is, but for how long it lasts and how long these high temperature days are impacting us. In addition, sea level is rising. I know we've been seeing a lot of this and hearing a lot of this in the popular press as well. And in addition to sea level rise, storm surge also is going up. So particularly in Massachusetts, where we so value our coastal way of life and our coastal properties and our recreational ability along the coast, it does impact each of us, not only those who are living right by the coastline. So I'm just going to take you through a few more of these photographs that show the type of impact these high intensity rain events can have. Infrastructure and property damage, and this is all from the New England area, and some of them are from Massachusetts. Natural resources are also being impacted. So it's one thing to have our infrastructure impacted, but when natural resources are impacted, it really affects the whole system. It affects the ability of our landscape to withstand more of these events in the future. It completely decimates the buffering capacity that our natural systems have. And we've sort of grown used to. You drive anywhere around Massachusetts and you see these small water bodies, a lot of wetlands, a lot of vegetation. All of those really act as great sinks for water during these flooding events. But when the intensity of these events is really high, it sort of decimates those areas and prevents sort of future buffering capacity. So that's sort of one end of the spectrum, which is sort of the flooding side. And on the other hand, we're also seeing, especially in the last 20 years, an increase in our dry days, our increase in the number of days where we're not seeing rainfall. So while we're seeing these intense burst events, we're seeing short to midterm droughts as well. And these are, of course, leading to not enough water in our rivers, so fish kills, habitat being lost as a result, but also impacting water supply. In 2016, if any of you live around Cambridge or drive around there, you would have noticed that the Cambridge Reservoir was really dry and you could walk on the floor of the reservoir. The Quabbin Reservoir, which is out in the western part of the state, had also receded quite a bit, more than its historical levels compared to its average in and out. So many of our reservoirs, the bottom right is Situate Reservoir, which was in real dire conditions until they put in a lot of water conservation within the community. So we're seeing many more of these drier days. And in 2016 in particular, that's probably what we would consider as one of our worst droughts on records since the 1960s. So we consider the 1960s as our drought of record, one of the worst that the state has experienced. That drought went on for between 3 to 5 years and really impacted water supply and so much more. It took several years for things to bounce back. We've had other droughts, but in 2016, 2017, that 1.5 year period was probably close in severity and extent. if you compare to the 1960s. Again, lots of brooks drying out, reservoir systems being impacted, agricultural in particular being very impacted across the state. We were lucky that in 2017, when we started getting the rainfall again, that, it was not just a little blip, but it was sustained and lasted a while and got us out of the drought. So this is sort of the trajectory of how the drought moved. The darker the color, the more orange the color, the worse the drought condition. Yellow, the light yellow is a level 1 drought. So we've had that intense drought condition for several months through the end of summer and into the winter in the 2016-2017 period. So after that came 2020. And I think most of us remember 2020 for the impacts that COVID had on our lives. But those of us that are in water world also remember it for the drought that it brought. And May through September, October is usually the time in the summer when we want to go out and want to have more water and experience more water outdoors, but also tend to use more water indoors. But that's the time when we were in a drought yet again. That drought lasted through this year up until about a month ago. So again, not so short term, fairly impactful. Luckily, this one was not that severe and did not impact agriculture or water supply quite as much because there was enough of a reserve from the previous year, which was a fairly wet year. So all of these have impacted things like stream flow, groundwater, and we at the state, through our drought management task force and through the Water Resources Commission, have a network of stations across the country that we manage along with the United States Geological Survey. And what we found is, of course, as expected, stream flow is going to go down, groundwater is going to go down during these times. But there have been these real record lows, which means that it's the lowest it's ever been since records were kept. And in some had records going back to 100, 120, 130 years. So that is pretty significant when what we would consider as not that severe drought causing these really record low stream flows and the record low groundwater. So I just wanted to put some statistics at the bottom, those of you who like numbers and want to have a comparison of in terms of precipitation or how much rain we get in an average year versus what we got in 2016, 2017, and versus our drought of record, which is 1960s. The rainfall we got was not so bad, but, we really saw a lot of record low flows. So, we all scratch our head and say, what's really going on? Our rainfall is okay. It's not that depleted, yet we're seeing all these incredible impacts on the natural environment, on stream flow and groundwater. And so to be able to really understand the problem, we have to kind of go back to the basics. Many of you may have taken some basic hydrology or water or environmental science type of classes, or even basic science classes in school or college. And you may have remembered learning about the water cycle. But what you may not have seen is that cartoon on the right that shows all of this development and impervious cover that is sort of a barrier to that water cycle. So as water typically would move up and down between the ground and the surface and the air and so on, here we're putting in these hard surfaces right in the middle, and boom, now this water does not go in and can't really evaporate either. It just is a sheet flow across those, or taken through pipes and just discharged somewhere far away. And that really is why we're seeing a lot of these very low flows in groundwater very low levels in groundwater and stream flow, because there's not enough that's really getting into the system. So what we would typically think as being a not so big of an issue, now we've suddenly changed the equation by 20, 30, 40, 60%. All right, why is my slide not moving? Okay. So it's all about really managing for the extremes. And the more and more we think about this, the more and more we realize that designing and managing to the average or the median, which is what we typically do, is really not putting us in a position to be resilient and be able to deal with these huge impacts that we are beginning to experience, both monetarily and on our public health, as well as certainly on our pocketbook. So it really is about managing both these two extremes because they're highly connected. So some of our takeaways from our recent droughts were that, well, climate is changing and Massachusetts is predicted to see more short and long-term droughts. We've started to experience this new phenomenon called flash drought. I'm sure many of you have heard the term flood. It's a flood that comes very quickly with a lot of velocity and a lot of extra water that you don't typically see, and it is fast moving. And the onset is fast as well and sort of catches us off guard. Similar to that is a flash drought, not quite the same time scale as a flash flood, but in drought sort of time scale, it is a shorter one. It comes quickly. It has to do with very higher than normal temperatures that are driving it. Conditions locally deteriorate much more quickly than they normally would. And we've started seeing that. We saw it in 2016. We saw it in 2020 as well. I talked about the above normal temperatures, many record lows. And so basically we need to have a much more integrated and comprehensive yet consistent approach to drought planning and mitigation. And in a minute, I'll get to why this is important for you folks and how the connection of this is with water conservation. So we really need to be better prepared and take a hard look at water use as well as land use. So what can we do at the state level? I want to just quickly go over some highlights of what we can do at the state level, what can be done at the local level, and what can you as folks who work in the industrial, commercial sector can do from your perspective. Pam, can you just give me a quick sense of how much time I have?
Yeah, about 5 minutes, Vanda.
Okay. All right. So drought mitigation, we do that through our Massachusetts Drought Plan. We actively promote water conservation through our water conservation standards and as well as through several of our regulatory programs. We have many grants on land use that help to bring back the natural system. We have our municipal vulnerability grant program that gives a lot of money to municipalities to assess their climate change and to kind of mitigate those impacts. Just quickly, we updated our drought plan in 2019. So we feel we're far better prepared to catch these extreme conditions and to start to do something about it. And one of the main things that we have in our drought plan on preparedness and response is in the development of a water conservation program, as well as having a local drought management plan. And I want to focus the rest of my talk on water conservation and the water conservation program. I'll skip this of what can be done at the local level, but I just wanted to quickly highlight some of the things that you can do at your organization, at your company, to help us as a collective meet these challenges that we're facing. One is to pursue water conservation. Can't say enough about the importance of water conservation, both indoors as well as outdoors. And for us to really take a hard look at the kind of footprint we are creating through our buildings, through our outdoor spaces, and really minimize that impervious cover footprint. Try and make sure that a lot of the water that is coming as rain and hits the ground has the opportunity to sink right in, right at that point, rather than be transported somewhere else. I really ask also all of you to sort of think about how you can be a role model for your local community. Very often we showcase what a community or what an institution has done on any of these topics and use them as case studies as well as places where we could take tours and learn from each other on. So I think for all of you within your own companies, it would be great to be able to showcase your efforts of decreasing water use. All right, so we passed our water conservation standards in a few years ago in 2018. It was an update to an earlier version. And basically, these are the sectors, the key sectors that we address: residential, public sector, industrial, commercial, institutional, agricultural, and public education. Today, I'll only focus on the ICI section and a little bit on the public sectors section. In addition, we also have a chapter on water loss control, on metering, on pricing, outdoor water, and comprehensive planning and drought management. And I wanted to put this in here because there are several aspects of, especially the water loss and metering sections, that I think would be very relevant to all of you to look at and incorporate within your own systems. So the public sector really applies to, and the ICI sector apply to industrial facilities, private sector, nonprofit, commercial facilities, institutional, municipal bodies, state facilities, and so on. And some of the key standards that we have in there is number one, do a water audit. I think all of us take some of our water use for granted, and we can't really do effective water conservation unless we know where the water is being used, how much of it is being used, how much of it is part of processed water versus sanitary use, how much of it is being used outdoor for landscaping. So I think before you even think about what can be done to reduce water, it really is a huge expectation from us for all our water users to go in and do a good water audit. You can, in some of the other standards that we have outlined in the water conservation standards, are installing separate meters for processed water so that you can really distinguish the different streams, but also be able to target your water conservation actions depending on the end aspect of your process. Implement water saving strategies. I would say having, a step 1, step 2, step 3 type of approach where you really lay out your various strategies is extremely helpful. Reuse treated wastewater. We unfortunately don't do such a good job here in Massachusetts of reusing our wastewater. It's common in some other parts of this country, and I would say very common in other parts of the world, where they treat it to some really high standards of use. No reason why we all cannot be doing that. Yes, of course, it requires some input of extra money and effort, but I think the results on the outer end are always helpful. Use best available water saving technologies, especially in buildings. And I'll talk a little bit about some of the new plumbing codes that will help us in advancing our technology. The water conservation standards also talks about lawns and landscapes and how we can have better water saving approaches there. Public sector standards, I know it doesn't really apply necessarily, and none of you are on the public sector side, but the standards that are in our water conservation standards as they relate to the public sector are also applicable to all of you. And these have to do with both indoor and outdoor water use. Okay, so here are some of the recommendations, and the one that is particularly helpful for us is to have our Office of Technical Assistance, which is Jim is here from OTA, as well as several others who have partnered with us over the years to think through the kinds of water conservation that companies can do, and also be a resource for companies to assist you all as you reach out to OTA for your toxic use reduction. All right, I just wanted to quickly go over a couple of things. Pam, I hope it's okay if I take a few more minutes. The climate bill was recently passed and signed by the governor. And yes, it's a climate bill. It has a lot on energy and adaptation and so on. But there's some particular aspect of it that has to do with water. And in the bill, there is specific language on how commercial dishwashers, steam cookers, faucets, shower heads, etc. You see the text at the bottom. All these products that are sold or will be sold as new products in the market have to meet new efficiency standards as laid out in this climate bill. And the efficiency standards are as follows. I pulled out those that relate to water use. So basically in the bill, they ask for an update to our Massachusetts plumbing code to increase the efficiency of shower heads, faucets, spray heads, aerators, dual flush tanks, water closets, dishwashers, etc., urinals, etc. All of you will have one or multiple of these within your institutions and within your companies. And I would strongly encourage and recommend that you look back and think about where in your facility these exist and start to upgrade to more efficient ones. So I'll end with just a list of some of the resources that we have. As you can see, we have our EPA Water Sense website listed here, and I'll use that as a segue to hand the baton over to TURA to talk about the WaterSense program. Happy to take any questions now or Pam at the end, either way.
I think at the end, thank you. Thank you so much, Vandana. It really set us up nicely, and we'll hear more about several of the measures that you introduced. So Tara, if you want to go ahead and share your screen. I'm looking forward to hearing more about what EPA's WaterSense program has to offer for our companies.
Yes, thank you so much for that introduction. And Vandana, you covered quite a bit of good background information that should get us started. So as she mentioned, the WaterSense program is a voluntary program that was launched by EPA to really help provide simple ways to identify water efficient products, programs, practices, and homes. The WaterSense label is the one that you see on the right side of the screen, and it can be found on products that are independently certified for water efficiency and performance. Back in the 90s, when low flow products first made it into the scene, they didn't all work very well. So each one of our specifications has performance requirements included. And so they have to pass that in order to be labeled. And each one is 20% more efficient than the national standard. We have products several that Vandana mentioned. We have about 37,000 product models that have earned the label to date, and they're in a whole bunch of categories, including flushing urinals, flushometer valve toilets, and tank type toilets, as well as shower heads and laboratory faucets for the indoor products. And then we have irrigation controllers and spray sprinkler bodies for the outdoor section as well. Spray sprinkler bodies are basically used to regulate the pressure within the sprinkler head, which can help it make a more efficient, basically more efficient use of water. So one of the things that we encourage people to do is to just add water to some of the other things that you've been doing in the past. I know a lot of you have probably been working on energy efficiency for a long time. So we encourage you to kind of include water along with wherever you're doing energy efficiency. So whether that's including it into your operation and maintenance procedures and procurement policies, we also encourage you to put it into your subcontracts and your service contracts, because many of the vendors may not know that you want to save water, but they can help you if you tell them that you want to. So they can add best practices to some of the contracts and also conduct some system audits on a regular basis for leak detection and repair. So they're already doing the work out there. You might as well have them help you with water efficiency at the same time. We also encourage you all to track your water and portfolio manager, which is the Energy Star's data management system, because you can track water and waste along with energy now. And then also, if you're considering replacing some products, check with your local utilities, because they often have rebates for many of these products. And it's not just your water utility. A lot of times the rebates come from the gas utility and the energy utilities as well. So as Vandana mentioned, SubMetering can be a very useful thing to do, because you don't have to wait for the bill to see if there's any problems. We encourage you guys to include submeters in a lot of your processes and any of the major using equipment that you have. One thing to touch on is that submeters in the water world usually don't need a separate utility account. They can just be for internal use only. So it's something to seriously consider, especially because the technologies have really come a long way in the past few years. There's a whole bunch of new water monitoring devices on the scene and other temporary flow meters that can help you and actually find out how much water each part of your building is using. You can also use them to set up alerts so that you're not just wondering if there's a problem. It can actually send you an email or a phone call just to tell you that there's a problem. So we usually encourage submetering any system that uses more than 1,000 gallons per day or 100,000 gallons per year. So that can include your irrigation systems, cooling towers, single pass cooling systems, and things like rainwater systems if you have them. One of the big points that we like to talk about is leak detection and to look for areas of water waste. The main goal here is to find the problem before you have property damage or damage to your assets, because there's often a damage that can occur with high water usage. So you can find some of these problems by submetering or reading your water meters, but you can also find them when you're doing a water assessment or a walkthrough of your facility, because those are just ways to see what's going on, keep your eyes and ears open, and also to work with your employees to try to do this as well. just to give you some perspective that the size of a leak really can add up to significant amounts of money. You can see that the small leak is about $400 a year on average in terms of losses. But if you get basically a leak the size of a pencil eraser will actually be $23,000 per year on average, which can be really significant for such a tiny leak. So the name of the game is to find it as soon as possible and fix it. To give you some other perspective, this is what the actual water usage looks like. We're all familiar with the garden hose. And if you see the one on the left, it's kind of a low flow out of the garden hose. That's about 1 gallon per minute. And that can add up to almost $5,000 a year in costs. If you look on the right side, that's a garden hose at full flow. That's what that looks like if you're using it in a single pass cooling situation. And that can add up to about $28,000 per year, which is really significant if you're, you don't need to pay it necessarily. So one of the main things we encourage you to do is to involve your employees in this process and to really train people like your custodial and maintenance staff to identify and fix leaks or malfunctioning equipment whenever possible. We encourage you to post signs. We pulled this one off the internet just to give you an example, but it's really just to show people why it's important and to tell them how to report the leak. Because many of them may see it, but they don't know who to call or who to talk to. So if you just put that information up where the water is being used, it can help to find leaks and report them. Some things you can do are just adding tasks to existing routines. Many of the times your facility manager is walking the property on a regular basis, so they could be checking for water running to floor drains near equipment. Yes, it's good to do intermittently, but if it's running all the time, that's an indicator of a problem usually. And so they can also check the meter during off hours, because if the meter is running while the facility is kind of shut down or inactive, you may have a significant leak. You can also encourage reporting or cleaning staff to report any dripping or clogged faucets and shower heads, since they're already there cleaning them anyway. And also one thing is to look for a little ripple at the edge of the water in a toilet bowl for a tank type toilet, because that can indicate a leaky flapper as well. You can also encourage your landscaping staff or contractors to look for any puddles or watering of hardscape, because those are waste. You can also look for things like broken sprinkler heads. After the lawn has been mowed, it can be a good time to just run the system to see if any of the sprinkler heads were broken off in the process. It's also helpful to look for dead plants and other strange things, because they could be indicators of a problem. If you have a kitchen staff on site, you want to really encourage them to shut down equipment between uses, especially things like food disposals, because they use a lot of water. Otherwise, if they have a steam system that they're using for a steam boiler or a steam cooker, you want to make sure that you're looking to see if any steam is leaking, because that is wasted water and energy. Just to get into some specific areas, I wanted to talk about water savings in restrooms. Older fixtures that were installed before 1994 use 5 to 7 times more water than a newer efficient model. So they can be pretty important ones to look at if you are looking for water savings. In this area, water savings depends a lot on user behavior, just like energy, but it also depends on maintenance as well. Unfortunately, water using systems or water using fixtures have components that will break down over time, such as valves, flappers, other parts of the fixtures can actually break down, and then they don't stop working usually at that point. Like an energy product would just stop working if there was a break in the circuit. Water systems usually just continue to work and continue to flow at a higher rate than normal when there's a problem. So we encourage you to inspect your valves on an annual basis and replace any worn parts. If you have any automatic sensors on fixtures, you want to look at those and calibrate them on a regular basis so that they're actually flushing or running when they're supposed to and shut off when they're not. Another thing is to regularly remove scale buildup and biofilm on all of your fixtures, especially faucets and shower heads, because that can lead to some inefficiencies. We gave you some steps. I'm not going to go through them right here, but each one, but we left you some steps so that you can figure out how to verify the flow rate of these fixtures. Some of it is just timing the flush cycle of a toilet, for example, and multiplying that by a value to figure out how many gallons per flush it is. You can also do a timed flow test with faucets and shower heads, and that's just to make sure that the fixture is running as expected. The WaterSense program labels a whole bunch of different technologies that basically are in every part of a restroom in a commercial building. The only one that we don't do is the public restroom faucets because the national standard is already very low. So these are all of the flow rates for WaterSense label products. So I encourage you to look for those if you're thinking of replacing a product. Another big target is mechanical systems. Many of you have a lot of mechanical systems in your facility, and they can actually account for 30 to 60% of your water usage, depending on what kinds of processes you have in place. And really, we encourage you to submeter these systems to make sure that you're monitoring them and checking for leaks and inefficiencies, especially when there's hot water and steam involved, because that is a big energy usage as well. We encourage you to minimize water use in single pass cooling systems, which I'll get into in a second, and to maximize cooling tower cycles of concentration. Single pass cooling systems is basically where the water flows through the piece of equipment or the system once before it's sent down the drain. And it's used to remove heat and cool equipment, which you want to happen, but it's not a very efficient way to do it. If you use these systems, a cooling tower is 40 times more efficient than a single pass cooling system at removing this heat. So you want to consider looking at different ways that you can minimize these single pass cooling systems. Some types of equipment that have them are ice machines, air conditioners, air compressors, vacuum systems, and refrigeration systems, but there can be others as well. Really, the name of the game here is to minimize the use of them. And if you can't get rid of them, we want you to maximize the efficiency of them while you have it. So use the minimum flow rate according to the manufacturer, and then make sure that you have control valves installed and that they are actually working. So you have to check them on a regular basis to make sure they're actually shutting the water off when you need it to. And then we encourage you to recirculate water when you can by connecting it to existing cooling lines or existing chilled water loops. In the long run, we encourage you to eliminate them completely by replacing them with air-cooled equipment and reusing the water in a closed-loop recirculation system. Cooling towers can be 30 to 60% of your facility water use, and it uses a lot of water to pump the water through, a lot of energy to pump the water through the system. So it can be a really big target for water efficiency and energy efficiency. One point to make is that evaporation is not the target for water efficiency. The evaporation is the main function of the cooling tower to remove the heat load, which we want to happen so you don't have overheated equipment. So we don't look at the evaporation as a thing to minimize in this case. We encourage you to do other things to monitor flow chemistry and monitor water chemistry and flow instead, and to maximize cooling cycles of concentration. The main goal here with cooling towers is to maximize the cycles of concentration, and that's really just an indicator of the number of times that water can be recirculated through the system before you discharge it to the sewer. And it's basically it's controlled and limited by the concentration of minerals in the water that can build up over time. So if you can work on this, increasing cycles from 3 to 6 cycles reduces makeup water by 20% and blow down by 50%. So it can be a huge savings. In order to monitor this, we encourage you to install submeters on both the makeup and blow down lines, so you can monitor flow and make sure that it's actually working as intended. And then if you are working with a cooling tower vendor or a water treatment vendor, that's a really good point to actually work with them for water efficiency goals, because they already have water reports that they leave every time that they come into your facility. And so they may already be doing some of this, but you really need to talk to them about it and monitor it over time by reading the reports and making sure that it's actually working as expected. We also encourage you to use makeup water submeters to measure evaporation losses. In some cases, the wastewater plant will actually give you a sewer credit if you can prove that the water hasn't reached the sewer. Usually the wastewater rate is based on the amount of water coming into the system, and they just assume that all of anything going into your system is leaving your system in the same way, which isn't always the case. So sometimes you can get a sewer deduct meter and they'll actually give you some credits from your utility off of your bills. Another area that's important is outdoor water use. It's not necessarily as intensive as some of the other systems like mechanical systems, but it is an important area. There are a lot of community benefits to having an attractive landscape outside, and it's a place that's easy to see and easy to monitor. For example, if there is a drought and there are watering restrictions, it's very easy for the utility staff to drive by and make sure that you're doing it correctly. So it's important to pay attention to this. And the important thing here is to minimize the amount of water that you need to use to supplement rainwater for the plant's watering needs. And that's really using things like regionally appropriate plants, drought tolerant plants, and others that are native to your area, because they'll be more able to work without additional irrigation water. You also often, if you're having a service contractor that comes in and does your landscaping, that you can work with them as well on your water efficiency goals, and they can also help you meet any requirements for local water restrictions. If you have people on staff to do this, there are a lot of courses and seminars that they can go to learn more about water efficient techniques. One of the main points that we like to remind people of is that irrigation water, about 50% of it is lost often to waste outdoors. And that's from wind or evaporation and overwatering, usually. That's caused by poor system design, improper maintenance and installation, lack of maintenance, and improper scheduling. So if you have these irrigation systems, we really encourage you to keep on top of them and make sure that they're working as you expect them to. Other things you can do are to find outdoor water waste, and these pictures are just some examples. The one on the right we call a geyser, because that's what happens when the sprinkler head is broken off completely. And that's obviously a big problem because it wastes a ton of water. But others may not actually be visible on the surface. It could just be an area underneath some hardscape that's starting to, dip down a little bit, which may be an indicator of a leak. So you want to check your system for broken or clogged sprinkler heads. Make sure that they're not tilted too high or too low, that they're actually watering the landscape and not your hardscape, like your sidewalks or your parking lot. You want to move or adjust the sprinkler to make sure that you're not watering pavement, and to look for any pooling or puddling. The WaterSense program works to actually label irrigation system training programs. So you can actually find an irrigation professional that has been certified by our program, basically, that you can find them and help you audit your system every 2 or 3 years. And that's something that you can find on the WaterSense website. We also have a whole bunch of other resources. We have things that are information by facility type, best practices. We have a whole bunch of water saving tips and assessment tools, as well as worksheets and checklists. One of the main ones I'll point out here is our operation and maintenance checklist, and that's one that we created just so that you could print it out and carry it around the facility with you to find areas where you can save water. This is just an example of that checklist to show you that we go through and tell you what things you can do and what things to look for. And then we also encourage you to check out more information in our best practices guide. So this is our best practices guide. It covers basically any water using equipment within a commercial and institutional building, but there are some that may be industrial uses as well, like lab and medical equipment. So in here, you'll find information on the operation and maintenance phase of each fixture or equipment, as well as things to think about if you're going to retrofit or replace that piece of equipment. So it can be a really good resource if you're looking to make some changes. We also do a series of webinars with Energy Star. We do a series of them every year. These are the webinars that we've done in the past few months, but we have another one coming up on December 8th that you can listen in on, or you can look at past recordings on the Energy Star website. We'll be doing another series with them as well next year too, so you can sign up and find out more information. I also wanted to mention a lean and water toolkit that EPA has made. I know that you guys had some lean training this morning, so this ties into that pretty well. It's basically created to help any industrial facility type and covers things that you can use, lean tools that you can use to find water waste. So things like value stream mapping, Gemba walks, doing Kaizen events, and root cause analysis as well. It can be a pretty good resource if you're trying to find processed water issues and fix them. Then also I wanted to mention, if you have a facility that was shut down for a period of time or is on lower occupancy than normal, you may have to flush the building's water system before you reopen. So I wanted to make sure, because of COVID, that I mentioned this at least, so that you have the resources that you need if that applies to you. Then I also wanted to tell you about a program that's done through the Department of Energy. It's part of their Better Buildings, Better Plants program, and it's a water saving network. Basically, it's a free program where participants are encouraged to set water goals and get for all or part of their portfolio. They have a whole bunch of information on their website, including some really useful tools and training. So I encourage you to take a look at this if you're interested. All you have to do is make a goal for your water savings and then kind of track your progress over time. And they have a lot of technical assistance that's available as well. One of the things that I found to be really useful is they do these in-house trainings that you can get done. They usually do them in person. And in the past year, obviously with COVID, they did a virtual one and posted all the recordings for it and all the materials. So if you're interested on how to assess your water use within your facility, this is really the place to go, because it really digs deep into the nitty-gritty of it, and it will train you on how to do it, because it's not just the tool itself, it's a whole bunch of other resources and training. The one that I'm going to talk about today is called the Plant Water Profiler, and this is their free tool that they use. It's an Excel-based tool, and it goes through how to find the water use throughout an entire facility during an assessment, and helps you systematically find if there are any leaks or waste in your system. And it kind of helps you to streamline the data collection, because there is a lot of data involved in this, but it can help you kind of focus on what you need and where. And then at the end, it provides you a summary report with some high-level recommendations as well. So I'm going to go through some screenshots of the tool just to show you what it does and what it is. So first, you start by entering some information about your facility and the plant's hours of operation, and basically how many days it's operating and if there's any downtime. Then next, you get into some information about what types of product that you make. In this example, it's a cottage cheese and sour cream facility, but it can be any type of commercial or any type of industrial process. Basically, then it talks about what processes or types of equipment that you have within the facility. And then they want you to kind of go through and put some data in about the process itself, so that you can start to evaluate whether it's actually going to work efficiently, or if you'd have some ways that you can improve it. It has some specific modules for cooling towers and boiler water systems, as well as restrooms, kitchens, and landscapes. This is the kitchens and landscapes part. They lump restrooms in with kitchens, which is fine. And basically it's just to organize your data into these different worksheets. And then after this, you go through and look at the system inputs. And this is where you enter information about how much water you're getting from which sources for which process. So this is just a way to kind of organize the data so that you can try to see how much water is coming into the system. The next one is the outputs. And so this is to just measure how much water is going out of the system. And in order to get this information, you do need to have submeters or flow meters on these different processes. They have some that you can actually just strap on to the pipe run that are called acoustic flow meters. And those can be helpful because you can move them around the system. You don't have to keep them in one place or permanently plumb them in. You can actually just move them. So things like that, or water monitoring devices, can be really helpful to get this information. After they've done that, they basically look and see if it matches, or if there's an imbalance in the system. So this is really to look to see if you have any unknown losses or any waste that you don't know about. This is one of the main outputs of this program and is pretty useful so that you know if there's a problem. The next is to look at some of the energy inputs of the process, because you can't really separate energy and water in some of these systems because they're interconnected. So this is looking at waste heat that's leaving in your plant in the wastewater. It's also looking at any energy that you're using to pump or use motors or fans. And these are in different parts of the processes, or the cooling towers or boilers, for example. So they're important to look at. Then it gives you some actual recommendations of what to do. And this can actually, there's 3 or 4 pages of this within their tool. And it can be a really useful one to look at how to, what you could be doing better on your process or in that piece of equipment. At the end of it, the main output is the true cost of water. So they not only give you the true cost of water by system, which is basically how much water is being used by each piece of equipment or each system, but they also give you a true cost of water by cost component, which incorporates the energy usage and the water treatment requirements as well. So the one in the middle is the one where you're seeing the actual cost of the system in terms of both energy, water, and chemicals or other outputs of the system. So in this case, it looks like cooling towers are the largest water use on the left, but they're not the main cost component in the system. They're actually a much smaller point. So you can figure out here that the amount of energy that you're using to pump and move the water throughout is actually very significant. So instead of focusing on the cooling tower directly, you may want to focus on the pumps and the motors as well. So it just kind of helps you prioritize what projects to do when. And then it gives you a comparison by the industry. This is by NICS code. And it really just kind of gives you some sort of sense of how you're doing compared to other facilities of your type. So it can be a useful one to see what percentile you're in terms of performance. We'll go back one. Nope, not going to let me. There we go. So this is the output of the program. And this kind of shows you the full picture of how water is being used, where it's being disposed, and how much it costs to do it. So this is a really, it is intensive to use this tool because it does require a bit of energy, your energy data, your water data, and a lot of SubMetered data, but it can give you some really useful outputs and can help you manage the process so that you're not just blindly going through an assessment, that you're actually doing specific steps to help do this. And the Department of Energy program has some technical assistance that you can get, but the Office of Technical Assistance would be the main place to go because Jim knows what's going on and who to talk to. So one thing that they do is they do lend out equipment so that you can try it out. So that's one thing to think about. If you want to try it out, you can join the program and test the equipment. So a couple other resources are there's a self-audit guide that's done by the Southwest Florida Water Management District. And that really goes through how to actually go through and look at each one of these pieces of equipment because it is kind of complicated. And then there's specific training on cooling towers that's done by the Environmental Defense Fund, as well as a tool that we have that's mostly focused on commercial buildings, but it could be useful. The only thing it doesn't include is processed water. So with that, I'm going to end my talk and I'm going to pass things over to Jim to continue the presentation.
Thanks so much, Tara. That was really, really a lot of information.
Yes.
So I encourage everybody to look at the slides afterwards to see some of the resources that Tara really touched on. Jim, you can go ahead and sit and share your screen now. I also wanted to point out, Kelly mentioned when you were talking about different ways where you can identify leaks, she said also to watch your wastewater treatment system flow. Big spikes indicate that there may be water coming into the system that you didn't expect.
Yeah, that's a good one.
Yeah, thanks. How you doing there, Jim?
I'm getting there.
All right. So Jim is going to talk about some specifics for us, and thank you so much for doing that. You can, yep, perfect.
Okay. Tara told us a lot of things about institutional and commercial, and at the tail end of her talk was part of what I was going to say, but it's very detailed. I like the Department of Energy's approach for energy and water, but it is very detailed. So you can extract from it what's appropriate for your facility. But so I just have here, of course, I was introduced before as engineer at OTA. And we're going to talk about why companies in Massachusetts conserve and why they might not. Some of the trends in Massachusetts in most recent years, say decades. Common areas to look for water use within a facility, and conservation practices and technologies. At the end, we're going to do a breakout session to look at a process and just identify a place you'd like to investigate for water conservation and propose some practice or technology, and then say how you might influence management to adopt your recommendations. Most of you know already OTA is a part of the TURA program, and we're not DEP or TURI, although sometimes we go on site and the person guiding us on the tour introduces us as such. Also, we're not EPA, but we are OTA, and we're the branch that does toxic use reduction and makes recommendations, whereas TURI does an educational part, as we're doing today, some research and grants, and DEP does the administrative and regulatory function. Because we're part of energy and environmental affairs, we do energy efficiency. John Rashko does some as well. And we're doing resource conservation as part of our mandate. I want to go back. We do on-site and remote. Unfortunately, we were remote for almost 2 years, and now we're back going to site visits and meeting people and seeing the real places. After a site visit, we'll develop some recommendations that you might want to consider, and we'll have some dialogue to see what's realistic and what needs further investigation. Some of the trends I noticed in the last 40 years maybe are stricter standards for wastewater is discharged directly to the environment. That's, say, municipal treatment plants discharging to a stream or water body. And also there were, in the past, more companies who would discharge that way as well. As restrictions are greater, some were directly from EPA on industrial sectors, and some just passed upstream from the local pretreatment coordinator who needs to comply with their permits. There's more groundwater sampling and remediation efforts for past industrial sites that were contaminated. We've lost many facilities in the 90s to NAFTA and Mexico, and after that to China. So some of the products that were low margin, I would say, have gone away, and some of the higher priced products have remained in Massachusetts. In fact, we've had growth in the biotech and high tech sectors. And we've had investment from Europe, I think, maybe because Massachusetts is a little bit better place to do business than Europe. Smaller facilities are being held to more stringent standards as the larger ones were in the past. There's improvements in instrumentation and controls. Electronics have gotten cheaper, more reliable and sensitive. This is our first polling question Pan's going to manage. What is the most likely reason that you think companies don't conserve water?
So go ahead and complete the poll. I've launched it and I'll keep an eye on how well we respond. It's just a single option. And some of the reasons that Jim points out are cost of water is billed to another department or location. So really having an externalized charge associated with it. Not aware of other associated costs beyond water and sewer that might influence your choice to implement conservation. Not having submetering or poor monitoring, making it difficult to really see where your options are. Water costs are included in overhead or considered not significant. Let's see, greatly delayed or no feedback when excessive use occurs. And then other reasons. If you said other, if you wouldn't mind just putting in the chat what you're thinking there. I'll give another couple seconds for the rest of you to complete your choices. And I will go ahead and end the poll now and share the results. So Jim, you can see the results there. Are you surprised that submetering is the biggest obstacle?
I guess not. I see so many, especially smaller facilities that have only 1 meter. It goes to the whole facility. And I think Tara said there are portable meters that can go around the pipe that you could transfer and do check-ins and what the flows are. But having a permanent installation in totalizer is a good idea.
Mm-hmm. So it looks like the rest are really associated with the costs. Why don't I stop this and do you want to go to the next poll?
Sure.
All right. So now we're going to look at, and you can go to the next slide. Now we're going to look at reasons why companies do implement water conservation. So again, for yourself or for your clients, look at this list and pick the reason that seems most applicable. Is it because there are seasonal restrictions of supply or quality that you're facing? Is it because your facility, I forgot to launch it, I'm sorry. Is it because your water rates or sewer rates have suddenly increased? Could it be because your company closely manages all of your operating costs? Are you considering water conservation to minimize the size or costs of new or replacement water processing equipment? Do you have corporate goals that you're facing? Or again, are there other reasons that you may be choosing to implement water conservation? And if so, please share that in the chat. And while the rest of you make your choices, Daryl shared that one of the reasons her facility does not implement water conservation is that product cleanliness has tight specifications, and to improve product yield, more flushing is often required. Older devices had lower quality specifications. Interesting. All right, I'll give it a couple more seconds. Let the rest of you get your choices in there. What are reasons why your company might consider implementing water conservation? And I'll go ahead and end the poll. And this time I will share the results with everybody. And Jim, are you surprised by what you see here?
I think I am. The corporate goals are much more influential. I've seen a few companies that are foreign owned, especially European, that have corporate goals. They're going to have some aspect that you're going to reduce by a certain percentage this year. Sometimes water pops up there.
So while costs are certainly a reason for doing so, corporate goals, corporate sustainability goals seem to be an overriding impetus driver for moving towards implementing water conservation. So really interesting to see. I'll stop sharing and you can go ahead forward.
So I thought the water rates and sewer rates would be a driver, but not so much by the audience. But I knew when MWA was doing a major upgrade at Deer Island years ago, a lot of companies were concerned about quadrupling of sewer costs. Same thing happened in New Bedford and other cities as well. So here we go. So common uses in the industry of water. Long ago, New England was attracted because there were a lot of streams for water wheels and mechanical drivers in the plant, but became less important with steam engines and such. And those same locations where you have turbines and microturbines, and sometimes a microturbine is appropriate when you're storing water at a higher level and bringing it back down. MWA brings water from central Massachusetts to Boston using, well, they use a low head for driving electrical microturbines. The power of water for cutting is used in softer metals like aluminum and elsewhere, also power washing. Very obviously, washing is used in laundries, and even the idea that countercurrent rinsing is used in some laundries to save on water. Extraction, cleaning and degreasing products, separation and classification, in the mining industry, but also used on a smaller scale in local companies. Electroplating, I've seen food processors pre-clean containers, make sure there's no dust in the container. And process equipment, of course, and the vessels that they're processing are clean. Also, many food manufacturers, to pick one industry, have nightly cleanings of the whole process area, floors and ceiling, maybe not the ceiling, but the whole place gets sprayed down. Mentioned in the previous talk, cooling and heating. There's a contact direct cooling or heating on the product. You see that in plastics extrusion, also pasteurized containers of product. Also non-contact, where you're maybe putting a heated or cooled fluid or water through the jacket of a vessel or other heat exchanger. Transporting of solids and ions. We have paper industry where you've got the pulp being put down on a web to make layers of paper. Dyeing, whether it's pigments or soluble dyes, electroplating, water treatment, and also particularly in semiconductors and microelectronics is cost of highly purifying water before use. Also mentioned cooling towers and scrubbers, sort of related. Scrubbers are intended to take out soluble contaminants or even trap contaminants that are solid. But one thing that can happen is a scrubber may be evaporating water while it's working. We have vaporization boilers are used for electrical generation and power plants. Also process heating, not so much as it used to be for area space heating. And you have cooling towers, mentioned. Air humidification, some industries need humidified air in the wintertime here. Machining, you have the coolants that are being used for machining. Some conveyors are kept wet or lubricated as they run. Another point I think was mentioned earlier was liquid ring vacuum pumps. If you have a rough vacuum, say half of an atmosphere, you might be using all your water in a non-visible way, maybe piped to the vacuum pump and leaving the pump down the drain. The intention is to keep the heat down within the pump, and you may preferably recycle the water through a heat exchanger instead of regulating it through the pump down the drain. Also, water is used greatly in beverages, soups, cosmetics, cleaners, coolants, paints, in these different forms. And then we're talking about practices and technologies. And reuse and recycling, we have recirculating water for cooling and heating. I mentioned increasing cycles of concentration in towers, closed thermal loops as part of the recycling, returning condensate to boilers. There's also an energy measure and also saving on the chemistry in the boiler. Limiting uses of city water once through cooling, has been mentioned again. Plumbing codes often say you're not allowed to do that for heating and cooling. And reverse osmosis. Many companies purify water with reverse osmosis, where you take a source like city water and you may utilize 2/3 of the water as a purified water, but the 1/3 is left behind and concentrated and discharged to sewer. But it's best if you can find a secondary use for that water. extending the use of the water by keeping it clean with filtration or removing oils or deionizing. Regulating pressures and line sizes, try to balance the distribution through the plant. Sometimes one area gets higher pressure and higher volumes and leads to higher usage when it's not necessary there. A very common technique is sequential rinsing and counter current, where you might move the clean water towards the dirtier water towards the initial product rinse. Evaluate the potential for dry processing if that's possible. And reevaluate quality standards for the water when it needs to be cleaned or discharged. Some other things, we mentioned submeterings and flow meters. I won't go into that. Check if the water meters are running. That was mentioned again. I had one case where a company did do that. Like on Saturday, he came in and he saw the water meter running and looked around, and he finally found a valve that was indicated to be closed, but it was actually open. So these things happen. And it goes along with monitoring and maintenance to see if valves are leaking or heat exchangers are fouled. Regenerating ion exchange columns, as they get older, there's less capacity to deionize. So you have to regenerate it more often. Some people send it out. They have cylinders at smaller scale, but larger scale operations may regenerate on site. So you have to use your acids or bases and then rinse it out before you start the cycle again. A few companies will have sand or multimedia filters, and likewise, you can get contaminants that lump up the media. You have channeling and less efficient use and shorter cycle times. Implementing spray regulation. I like the water hose picture that we had earlier. I've done a few water audits that we don't actually measure at OTA, but if we see a flow, we try to eyeball it like that, 1 gallon or 10 gallons in there. Implement sprays when you can instead of like an open hose. We try to recommend to fish processors that the operators don't do target practice on the fish on the floor. Adding sensors and timers to the valves that shut off automatically when nothing's being processed. When there's intermittent use in an area, it is kind of common to leave things running until the next product comes through. Minimize evaporation from scrubbers by trying not to put uncontaminated air from general ventilation through the scrubber, thus evaporating more water from the scrubber. I mean, you're talking about cooling. Oh, that's a scrubber in that case. Item on the cooling towers. In the wintertime, our cooling towers in Massachusetts work pretty well by contact with the cold air, less evaporation. But in the summertime, it depends more greatly on evaporation. I want to caution companies as they get close to being zero discharge, if they're doing some things internally that have an exemption because they are discharging, called hazardous waste exemption. Be careful you're not losing your exemption and be considered to be treating hazardous waste. Whoops. Water is a major constituent of the product. Think about distributing or selling more concentrated forms for less water use and smaller containers. And that's my contact information. I want to also mention that OTA has a fact sheet. If you just search for this OTA water conservation fact sheet, and you'll find like a 4-page document. It has many of the items that were mentioned previously.
And we've included that on our materials.
I don't think it's on the site yet.
Okay, I think, okay. So great, thank you all so much. We have a few minutes left and I want to encourage people to go ahead and just unmute yourself and ask a question of any of our speakers. Also, I noted that Dave Brisbois mentioned that the reason that they do water conservation is that they monitor their water usage to prevent excessive water going to their waste treatment system. So that connection between water use and wastewater treatment is a real important one for industrial users. Any questions for anyone on our panel?
This is Vandana. I just wanted to comment that it's great to see that so many companies have as part of their ethic a sense of resource reduction and water use being one of them. I think that's incredible that so many of you have that as part of your day-to-day approach to your resources, and in particular for water. I mean, knowing fully well there are constraints in terms of you having to flush and do other types of specific activities that do use more water. But in spite of that, having that approach and ethic of trying to conserve as much as possible, I think is terrific. So I certainly commend you all for promoting that within your companies.
Yeah, great, thanks. Jim, Sandra has a question for you. Could you please elaborate on hazardous waste exemption for zero discharge and a citation where that's covered? Maybe if you don't have the citation right off the top of your head, you can send that to her later, but can you explain that that comment a little bit more?
I think she got it backwards for Heidi when I presented it. There's an exemption if you're treating wastewater for discharge. So you can do things that otherwise would violate hazardous waste treatment rules. But if you're not discharging, then you don't have the exemption. It becomes a problem. Although I've seen some cities issue non-discharge permits. It's a little murky sometimes, but it's something to be aware of.
Right, any other questions for any of our speakers? Okay, well, I think this was really great. I think, it's important for us to remember that, the availability of water is going to be changing with the years, as Vandana kind of laid out. And so it's even more of a reason to get real about water conservation. Liz, did you have a question?
Yeah, I just want to say in the chat, someone has said, what is the rough contribution of failure to properly upgrade infrastructure for population growth and engineer for runoff versus weather? Anyway, it's kind of a long question. I think
Anyone want to
the issue
handle
is
that?
around upgrading
Probably a long answer.
infrastructure.
Jim, do you want to
No, that's
unmute
not like a
yourself?
Vandana question to me.
Yeah, I'm not sure what rough contribution we're talking about. Are we saying that how much does
Well, maybe I can
improperly sized
help with that.
infrastructure? Yeah, go ahead.
Yeah, maybe I can help with that. Like, is it 50-50 or is it all weather, or not? It's not going to be exact for sure, but is there a rough idea? There's obviously lots of factors that impact runoff and drought conditions when there's not water available for the uses that are needed. So obviously weather's part of that, and the other part of it is how do you manage and upgrade infrastructure and runoff from changing the ability for the earth to absorb rain as it falls. I mean, I went back from my old engineering days more than 40 years ago. One of the first things we had to do is if we developed something, we had to figure out how to manage and stop that increased or the more rapidity of runoff versus what the condition was before it was developed. So my guess is that there's factors in both areas, and I was just wondering if you had a rough idea what the contribution of between the two of those, which is one more dominant than the other, or are they both roughly the same, or is it weather or what? I just wanted your idea on that. That's all.
So I'm still not fully understanding. So you're asking, is the failure of the infrastructure due to weather-related changes, or whether it's due to population growth and development putting more of an impact on it? Is that a fair way to rephrase your question?
I believe it's both, and
right.
I think you believe it's both.
I'm just trying to understand your question. Is that what you're asking?
Yeah. So what's if you had to guess, what's the bigger contribution?
It depends on time scale. The impacts that human growth and population that they have had on the water cycle over the course of the last 50 years has is exponentially higher than what we're seeing in the past as climate change. So certainly we humans, the way we have engineered and orchestrated and built our environment has hugely contributed to changes in our hydrological regime. Now, with climate change and with seeing more of these extreme weather events coming our way, we know that'll only exacerbate it. So everything else being equal, if we can minimize our impact by building differently, by accommodating higher flows differently, by making sure that we put we have right-sized culverts in place, that we have the right type of buffering capacity, that we make sure that we recharge where we need to recharge, and not send the water off somewhere else. I think those types of things will minimize the impacts of climate change on us and minimize how much we are influencing the hydrological regime. So both of them are at play, but yet our human influence on it right now is pretty strong and has been quite significant.
There were programs like combined sewer overflows to preserve the wastewater treatment plants. And 10 years ago, we had I-495 conference where there was a lot of development along I-495 because it's open land, it's high land. Because it's high, it's also short of water because it's the beginning of streams.
Mm-hmm.
There was a lot of things happening, a lot of factors at play.
All right, well, we are at 3:30. Thank you all in each so much. Lucy, you were just waving goodbye, right? Yeah, okay. Sorry, I saw a hand. So thank you everybody for joining us. As I said, I'll try to get the surveys out to you this